Hello everyone, we are Team Hackweisers and here we are going to present our project for network and data security subject. We are a group of 4 members including me, Paramveer Desai, Kush Darji and Soham Nipulbhai Shah. We have implemented 2 attacks. I and Paramveer are involved in Mitnick Attack and Kush and Soham are involved in Local DNS Attack, and the task bifurcation are as shown here in the table. So first we will go with the Mitnick attack. So it is a special type of TCP session hijacking attack. In 1994, Mitnick successfully launched an attack on Shimomura's computer, and by exploiting the vulnerabilities of the TCP protocol, he executed this attack. It is not just an hijacking existing TCP connection, but it is a special type of TCP session hijacking in which he builds a TCP connection between A and B terminal first and then naturally hijacks this connection. So first we will go with the configuration. So Shimomura often needed to run remote commands on X terminal. So to avoid typing passwords again and again, he created our host file on the X terminal and put the trusted server's IP address into the file. So, to simulate this attack, we are also doing the same thing. Now, the task 1 includes adding the cache and adding an ARP entry to the cache. We need to store the ARP cache to get the access without asking for the passwords. So first we need to set up a connection between trusted server and X terminal, and for checking whether we have set this connection well, we are using RSH date command, and then we need to verify that we have this entry in the ARP cache using ARP-N command. Next, we have task 2 for spoofing TCP connection and RSH data. It is further bifurcated between task 2.1 and task 2.2. Task 2.1 is to establish the spoofed TCP connection. So first, an attacker sends this spoofed SYN packet, and after the X terminal sends out SYN plus acknowledgement packet, trusted server needs to send back the acknowledgement packet, in which the acknowledgement number should be the sequence number plus 1. In task 2.2, we are setting another TCP connection, but this time it would be with port 9090 of the trusted server. If both the connections are established successfully, RSHD data will execute the commands in the RSH data packet of the payload. Next, most important part is setting up the backdoor. So what is the case now is we have to write the commands again and again and launch the same attack again and again. It is very inconvenient. So Mitnick came up with a plan to set up an backdoor in X terminal after his initial attack. So now I would like to hand over to Paramveer to continue with the execution of the Mitnick attack.
Thank you, Batsri. Now I will show you the execution of this attack. So we will now open the C lab, and here we are setting up our environment, and here I will show the build using the docker compose build command, and also I will show you the containers that we will use during this attack, which were used during the original attack. So you can see that we are creating 3 containers, namely seed attacker, which is attacker, the state server, and the X terminal. So our containers are set up. Now here I will show you that it has created successfully and is running. Here you can show the IDs of it and the containers that are created. Now I will open another terminal which will act as an X terminal. So here I will execute it using the docsh command and the ID. Here we have successfully entered into the external container. You can see the IP address over here. Now we will use the seed command to seed into it. Also, I will show you the existing files that are existing here and within the terminal. Here we will make .rhost file as it is the file which the configuration checks whenever the ARP cache is either stored into it or not. And we will also write the IP address of the trusted server into the .rhost file, which will make the attacker log into the external whenever he wants. And we will also give the rhost permission like for all users can use this file. Now I'll show you the rhost file to confirm that our IP address is successfully stored into it. This is the basic configuration that we are using, as Xterminal has the ARP cache of the trusted server, so the trusted server can access Xterminal anyways. Like this is the configuration of the original stack. Whenever the Shimomura needed to launch commands on Xterminal, he used to log into trusted server to avoid using passwords. So in this Mitnick attack, we are using that, imitating, impersonating that. So now I will open the trusted server here. I will execute it using the ID. So here I'll show you that we have successfully logged into the trusted server. So this is the trusted server's IP address. Now to establish the connection between the trusted server and the external and to show that they have successfully connected, I will use the rsh command using the external's IP address here and the date command. So here we can see that connection is established between two things and the date is shown of the external. Now again back going to the external, I will show you that the ARP cache is successfully stored. So here we can see that the ARP cache of the trusted server is stored successfully into the external. Now to stop the trusted server, as like Mitnick did it using the same flooding attack, but it is covered in the lab. So here we will close it manually and then we'll proceed into attacker to launch the attack. So here we are stopping the trusted server. Trusted-server. So you are closing the trusted server to, like, basically it is muted or it is shut down by same flooding attack, but we will not waste time on it and we will just stop the trusted server so it does not respond to the external. Here I will show you that the trusted server is not working and just the external and the attacker is working. Now to launch our Python script and the code that we have written to execute this attack, I will go into the volumes folder where the code is there. Here we will also put the ifconfig to get the interface ID, as interface ID is required every time we execute the script that we have written, as it needs the interface as a parameter in which the attack is being performed. It is changed every time, so we have to perform this step every time the attack is repeated. So now I will go into the attack.py file that we have, the script that we have created, and I will replace the iface, that is interface ID, as it is necessary to replace it every time. I'll save it and run my sudo, like my Python script, into the same interface that we have used this ID. So here I will run the command sudo python3 attack.py to execute the attack, and I will also open Wireshark parallel to it to sniff the packets. Now I will launch the attack. Here you can see that the packets are being sent and the TCP connection is established. We'll stop this and we'll go again to the Wireshark to see it. Here we can see that the connection, the three-way handshake, has been done. Here we can see the acknowledgement, the acknowledgement, the SYN, the SYNAC and the ACK file. Here we have all the information. I will explain this packet trace later, and this session is established, and here we can see that the data that we have been loaded in the Python script has been loaded. But later on I will explain the code and this packets later on. I will continue with the attack. So after this attack I will go back to the my terminal, and we will now open the attacker. We will seed into the attacker to use the X terminal because the attack has been performed and the X terminal is compromised. I will take the ID of the attacker to log in as attacker. Now we are into the attacker container. We can see it using this command. Here we can see that this is the attacker's IP address. We will feed into it and then use the rsh command and the X terminal's address. Now here if the attack is successful, here we should be logging into the X terminal without any password required. Then we can say that the attack is successful. We'll just run this command. Here we can see that we have successfully entered the X terminal. Now here we can see that the IDs are mismatching, and here we can confirm that we are into the X terminal, and now the attacker has the whole access of the X terminal. I will demonstrate it by creating a demo file. First of all, let's go to the X terminal container and see which files are present over there. Here you can see that we have only this files like ROS files and other files, but now I will create one other file through attacker container. So let's set touch test.txt. Let's create a test file. Now we can go into then check it again, like whichever files is present. Here we can successfully see that the test file is created. Now any command we can run over the X terminal if the X terminal is compromised and the attacker has been present in the X terminal machine. So here we can see that the Mitnick attack has been successfully performed. Now I will hand it over to Bansri to explain the script that we have wrote and also the Wireshark packets that we have sniffed. Thank you.
Thanks, Paramveer. So I would like to now continue with the Python code. So here we go for the attack.py, which we used to execute this attack. So first of all, I would like to start with the scapy library. So we have imported the scapy library, which is used by Python for sending and receiving the TCP and UDP packets. We have imported this library. Now then we are initiating the terminal, like IP address of the X terminal, its port, terminals of the trusted server and its ports. Then I would like to directly go to the main function. So this is the first we have called the spoofing scene function. It executes the task 1 from the documentation, which says that we have to spoof the TCP connection in which the trusted server sends the spoofed TCP sync packet to the X terminal. So we have used here the source IP address of trusted server, and destination is X terminal. And the same is for the TCP layer. We have used source port of 1023 and destination port that is of X terminal 514. And as we are sending the spoofed scene packet, we have used the flags as NS, and this is the sequence number. And then we are sending the packet using the send function of this KP library. So as soon as we send the spoofed sync packet, I would like to go to the Wireshark trace simultaneously so that I could explain it well. So as explained, the TCP connection is set between 1023 to 514 ports, and sync packet is sent from trusted server to X terminal. The X terminal will send back the sync plus acknowledgement packet and it would have the acknowledgement number, which would be +1 of the sequence number of the previous packet. Now, as the trusted server receives the sync plus acknowledgement packet, it sends the acknowledgement packet back to the X terminal, which is executed in our code using this function. So we have the function called spoof packet, and we are sniffing the packets using the sniff function, where we have set the interface and filter to TCP and source host of 10.9.0.5, that is of the X terminal, and PRN is the function which would be applied to every function sniffed through this sniff function. So in this packet, first we would compare if the old TCP flags is SA. So in our case right now it is SA because SYN plus acknowledgement package is sent by the X terminal to the trusted server. So it will go inside this block, and we will get the print of sending spoofed acknowledgement packet. It will create a new packet in which it would send the ACK packet, and it would have the data of 1990 X00 seed. So this is the format of the RSH data. It includes first the port, then the data to be sent, and again the file in which we have to write it. Then this packet is made using IP layer, then TCP layer, and the data payload data, and sent using the send function. So now, when this payload data is sent, it has the port number of 1990. So we set up a second TCP connection, which I can show here in the Wireshark trace, which is here 1023 to 1990. So first SYN packet is sent because that command is to be executed in the RSH data, and then it will get the SYN plus acknowledgement packet and the acknowledgement packet once again. So we have set up two times the TCP connection, and then after that, when the TCP connection is set, when the user tries to send the data, it will not get the reply because the attack was successful and we have successfully executed this attack. So this was all about the packet trace. I would like to go back again to the source code. So yeah, this was all. This is for the 1990 packet trace. This function, this condition is for that. And yeah, so this was all about the Mitnick attack. Now I would like to hand over to Kush to continue with the local DNS attack.
Thank you, Banshi, for passing the opportunity. Hello, everyone. My name is Kush. Being a team member, we have implemented another attack that is local DNS attack. Me and Soham will explain and try to execute it further. So, what is local DNS? In a layman language, it is a domain name system used to take a name backup and is usually located on the network to which the computer is attached. When we try to access any website, typing a domain name, the local DNS will convert to that specific IP address automatically using a query process. We have executed 4 tasks of this attack, including the environment container setup. Now I will explain the environment setup. So as you can see in the below window, DC build is used for building the container image. Uh, DC up is the command used for starting the container. Then after the doc ps is used to format the ID and the name. So further, the doc sh is used for Docker execution, and here you can see the attacker name server is being executed using doc sh. Similarly, I have set up the user, seed attacker, and local DNS servers as well as the seed router. So now we will now I will try to explain the task 1. So task 1 is about the spoofing the response to the user. In this task, the attacker targets the channel between the user system and the local DNS server. User makes a DNS request to resolve the IP address of the host name, and attacker will sniff that and spoof the fake DNS response that arrives before the original response comes. I will take the command on the website that is www.example.com. The Python code will launch attack, and through seed attacker window, a user will get response from the fake server, which will be stored in the local database of the local DNS server, and we can observe the response from the cache. Now I will try to execute the task 1. So in the seed attacker, I have already set up the Python file, and firstly we need to clear the cache of the local DNS server. So RNDC flush is used for the clearing the cache from the server. So as you can see that seed attacker has launched the task1.py, and in the user terminal we have to take the command and example.com. So here you can check that the user is receiving the fake IP address, that is 1.1.1, and in the attacker terminal you can see that the DNS resource record is been received, and the R data, which is set as the fake IP address in the Python file, is received to the user. So this was all about the spoof packet, which is directly been attacked by the attacker, and the packet is received from the attacker's server. So further I will explain the task 2. So task 2 is all about the DNS cache poisoning attack. In this attack, we will target the local DNS server and spoof the response they are giving to the user machine through cache poisoning. Once the local DNS server cache is spoofed, then the user makes the request to resolve the hostname, and DNS server will always give the same response. The user will take the same website, that is www.example.com. The Python code will launch the attack, and it will spoof the response of the DNS server, and this will get stored in cache. The response will contain the fake IP and data. It can be visible from the packet in the seed attacker window, and we can also see the spoof cache in the DNS server window. I will try to execute the task 2. So firstly, as we all know that we have to clear the cache from the local DNS server, and in the attacker terminal I have started the task 2, and as usual that we have to run the dig command in a user terminal, and now you can see that the fake IP address has been generated, and the data and the spoof packet has been received to the user is shown on the seed attacker terminal. Now we will also check the clear. Firstly we will clear the cache and check by using the grep command, and here as you can see that example.com is receiving the fake IP address. So this is all about the second task, and now I will pass over to Soham to explain further two more tasks.
Thank you, Kush, for passing me the charge. Now I will explain the task 3, which is spoofing NS records, which is the name server records. In this task, we will attack the whole domain of the example.com, and we will spoof every reply that is obtained from the servers of example.com. The request obtained from the local DNS servers of querying the hostname example.com will be transferred from the server of example.com to the name server of ns.attacker32.com. So user when will take any domain of example.com, for example mail.example.com or ntp.example.com. The user will always get a fake IP address which is provided by the attacker name server, which is ns.attacker32.com. uh, so now I will try to execute this task in the seed lab. I'll switch over to that, and as we can see in the attacker's window, I'll stop the second task, and firstly clear the cache by using the flush command. Uh, Now I will start the task 3, and the task has been already started. And now we can firstly I will dig the www.example.com and see what the results are. Yes, so we can see that the fake IP address has been received at the user side, and on the attacker's window we can see that in the spoofed packet that is received from the attacker server is ns.attacker32.com, and we can see here that www.example.com is being giving out the fake IP address, which is our data is 1.1.1.1. And uh, now let's try another domain of example.com. Let's try mail.example.com, and as you can see, we are receiving again the same fake IP address which is defined in the name server. And if I open the name server window here, we have made the zones over here, so we can see that 1.2.3.6 is for star, which is basically any of the domains of example.com, and it is being received from this ns.attacker32.com, which is the name server of the attacker. So let's try to dig another one, which is ntp.example.com. So again, it's gonna receive the fake IP address all the time. And now we can see here that the query time is 0 milliseconds because the cache is already stored in the local DNS server and it's always giving a fake response. So we can see by dumping the cache in the server, and now when I find example keyword in that file, you can see over here that all the fake IP address and the name server also is being listed over here. So the local DNS is poisoned by the fake IP address of example.com of the whole domain. Now I will move further towards task 4, which is targeting another domain, which is a more advanced thing of the local DNS attack. We will basically target every domain that is requested by the local DNS server from the user. So for the project purpose, we have used google.com, and in this manner we can also target other domains like facebook.com or yahoo.com. So basically in this attack, all the other domains are targeted for the specific local DNS server request. When the user will dig a specific URL, then the request is received to the local DNS server. We target a particular request and spoof the request received at the local DNS server. So this is the main novelty of our whole attack. So basically, we are changing the Python file in such a manner that for a particular IP address, it has been received on a attacker's name server, and always a spoofed response will be given to the user for trying out domain of google.com. So as you can see from the screenshots that google.com is requested by the user, and we are giving out a fake IP address to the user. So this task is basically the main task, I would say, uh, because whenever a user types any domain of google.com, he or she will receive always a fake IP address. And let's try by launching the attack. I'll stop the current attack. Firstly, I will clear the flush the cache which is stored in the local DNS server. Now I will launch the attack. So it is telling us that please go to the user window and type command like example.com and google.com. So basically for the project purpose we have targeted google.com. So let's dig www.google.com and see what response the user has been receiving. Okay, so here we can see that the user is receiving a fake answer section, which is in that the IP address received is 1.1.1, which is the fake IP address which is being received from the name server of the attacker. And also we can see in the spoofed packet which is received from the attacker server here that www.google.com is always receiving a fake IP address which is 1.1.1. So this is the whole DNS record which can be seen from the attacker's window, and this is the packet that has to be sent from the local DNS server and which is catched by the name server of the attacker. So we can also see uh, in the local DNS server by dumping the cache, and we will search for the word Google in the database file and see what the results is being stored on the local DNS server. So we can see here that google.com or any of the google.com domain will always receive 1.1.1. So if I try and execute another dig command on www.google.com, keep your eye on the query time. It will give results from the database or cache that has already been stored on the local DNS server. So here we can see the time is always reduced and we are all receiving the fake IP address. So this was all about the task 4. Thank you for listening to our presentation of our project. Thank you so much and have a great day. Thank you.